Okay, so you've marked up your code and you're ready to do your first telemetry capture. The first step is to open telemetry. It should look something like this. In these demos, I have a mouse overlay so that you can see exactly what mouse buttons I'm pressing and what keys I'm pressing to help you learn the interface. So I'm going to go off screen. The next step is to run the game that's been marked up. So I'm going to go off screen and run my game. Now I'm going to run around in my game to help generate some data here. So I'm going to be off screen for a second. You can see the data coming in there in the workspace tab. So I'm running around in my game, shooting some guys, hopefully generating some good data for us to look at. Okay, so I think I got enough here. Let's see. So we can see the name of the game, the date and the time. We can see the duration of the capture, which is still running, the number of frames that we've captured, how many zones we've captured. On a platform that supports context switches, we'll see that we've captured, context switches here, 24 plots and 686 messages. If we want to see the live data, we click on timeline, and the timeline view shows all of your zones organized by threads. Each thread is represented as a track in the timeline. We can left click and drag to zoom around in the timeline, so we can pan up and down would go, see all of our tracks, and left and right goes forward and backwards in time. We can right click, drag to zoom, so we can zoom in on a certain portion by using basically a selection window. We can also use the mouse wheel. So mouse up will zoom in centered on the cursor, and mouse down will zoom out centered on the cursor. We can click on any zone, just left click, and that will zoom to the extents of that zone. As you mouse over zones, you'll see tooltips that tell you information about that zone. So you'll see the name of the zone, the duration, the source code file name and line number where that zone was declared, how many clocks it took, how many immediate children it has, and how much of its time is accounted for by those immediate children. You can also right-click on any zone to get a breakdown of exactly what's happening in that zone. So here we're looking at this bullet step. We see that we've got dispatch all collision pairs taking 58% of the time, or 3.76 milliseconds, and there were 8 calls. Here we've got update axis align bounding boxes taking 9.5% and representing 613 microseconds of the bullet step. So there are some hotkeys in here to help us out. So the home key will take us back to the start of the capture, and the end key will take us to the end. And in the case here where we're live, it'll actually stick to the end so we can kind of see the data coming in as it goes. Now across the top you'll see some red spots, and these are determined by our bad frame threshold. Over here in the settings we can say what our bad frame threshold is. Now our game is running at 60 hertz, so we're expecting our frame times to be a little over 16 milliseconds, so we have our bad frame threshold set to 17 milliseconds. So anything over 17 milliseconds will show up in red. So even here we're zoomed out on a 3-minute capture, we can immediately see where our bad frames are. So if we zoom in here, we can see that this frame was 24 milliseconds, and it looks like most of the time was in present. So we missed a VSync here. Now there's a hotkey to jump to the next bad frame, which is F. So F will jump to the next bad frame. Here we got another 21 millisecond frame, and this is actually the last bad frame. And D will jump to the previous bad frame. So this one was a much longer frame, was 28 milliseconds, and I'm printing out either my name or one of my coworkers' names every time I fire the gun. I think this was the first time I fired the gun, and I'm waiting to load the bullet model. So that's what took a long time here. Okay, so these thread colors here, we can change those. If you click on the tracks button at the top right, you'll get a legend, and you can leave that up if you want, or if you want more screen real estate, you can bring it down. But if you click on the color swatch, you can actually change the colors of these threads. And these values are saved on exit, and so you shouldn't have to do this very often. So anytime telemetry sees a thread named main, it's going to use this color. And so you can use these preset values, or you can use the HSV RGB sliders to change the colors of these threads. Okay, so down here at the bottom, we've got things called time spans. Time spans are kind of like zones, only where zones are hierarchical and they stay within a certain thread. Time spans represent things like asynchronous I/O or holding a lock, and that stuff could span or could go across several different threads. So we show them up as time spans. They're drawn a little bit narrower than zones to distinguish them, but they really just represent like a chunk of time where you're doing something asynchronous. So in this case, we were holding the view lock for three milliseconds here, or this is holding the swap lock. This was where I made a time span for how long it took us to tick the physics, and you can actually see that we're holding the lock for the entire time that we're ticking physics. So my M_CS physics is a critical section for the physics system. We can see context switches here as well. So this shows us which core each of our threads are running on. So in this case, worker 2 is on core 2 here. And then we can see worker 2 right here is actually on core 3. So on Windows, we're at the mercy of the scheduler. So our threads kind of jump around from core to core. On a console, you'd probably expect to see more thread affinity where threads stayed on a particular core. Okay, so let's take a look at plots. So we're going to look at 3 graphics plots here. Now we haven't been running around, so all this is pretty flat, but over here in the beginning where I was moving, there's more interesting data. And we're looking at the triangle count, instance count, and draw call count. And you see that these are very correlated and they kind of overlap, so we can space them out to let us look at them independently. So here we've got, this is kind of an interesting spot where we've got, 2.8 million triangles, 18,000 instances, and 700 draw calls. So let's say we want to zoom in on this particular portion. And it's similar to the zone view where you right-click drag to zoom in or use the mouse wheel. But you can also right-click drag a vertical section. So we could find a particular part. Let's say we were really interested in where we hit our maximum triangle count. And now let's say we want to look at that with respect to zones. So we could come down here and tile these 2 views. And you can hold down the control button to synchronize your visible views. So now we can zoom in on the spot where we hit 2.8 million triangles and actually look at the zones that correspond to that. So if this was an interesting, usually you look for spikes in your plots and then go back and look at your zones to try to find some correlation to what's going on. Okay. We can also look at messages, and messages are just like a log. So you can see all your log messages printed out. We also have ways to filter them based on warnings or errors, so we could turn off our log messages and only see errors. Errors are drawn in red and warnings are drawn in yellow. And as a test, I was just printing out one of my coworkers' names every time I fired the gun and flagging it as a warning. So we can double click on any one of these and it'll take us to that spot in the timeline. So we can see that this is where I printed the Dan message. I had a Dan zone to match up, so we can go from the message view to the zone view. That's a quick run through of telemetry. We'll get into more detail on everything else in other videos. I hope this gets you up and running quickly.